And we can start, finally, Mario, we can start with the first plenary that I have really the honor to welcome and to introduce our first keynote for this plenary, Professor Mario Small. He is currently Catholic Professor of Social Science at Columbia University, where he also served as chair of the Department of Sociology, but he was previously at Princeton University, University of Chicago, and Harvard, where he got his PhD. Professor Small is internationally recognized for his contribution on social network and social capital, urban inequalities, and I would say social networks methods, in particular qualitative and quantitative mixed methods, and how to deal to these methods. And I would love so much to discuss Mario Small's work, which has been groundbreaking in many respects, mainly with the idea of organizational embeddedness, but I will simply not have the time. I will simply say that both Villa Victoria and Unanticipated Gain, and I use the short title, received the Wright Mills Award for Best Book, which is quite unusual, 2 times the same prize. And Someone to Talk To received the James Coleman Best Book Award. He was also honored with the Robert and Helen Lynn Award for Lifetime Achievements in Community and Urban Sociology. He was Associate Editor of the American Journal of Sociology, and he is currently editorial board of the Annual Review of Sociology. So I've stopped here because we really want to listen to your speech. So it's my pleasure to give the floor to Professor Mario Small.
Thank you very much. It's a real pleasure. Thanks for that lovely introduction. Thanks to all for the invitation. It's my first time in Vienna, so it's a real pleasure to be here in this imperial room and in this biblical podium. Let us pray. All right, I'm sure that there are slides here. There they are. Beautiful. I'm going to get right to it. The talk today, the data revolution and the study of social inequality, promise and perils. The context is pretty straightforward. I think we're in a time of transition. And I am not really talking about the AI revolution, although yes, it's happening. It's changing how a lot of people do their work. It's already made its way into papers. It's already possible to detect what proportion of papers use AI across the social sciences. That proportion is increasing very rapidly. It's already possible to detect the impact on the quality of the work. It's exactly what you think it is. There are more papers per author among authors who use AI. The quality with respect to imagination has gone down. So a lot of this is happening, we know that. But I think it's worth talking about something that's, I think, equally important and maybe less flashy, but probably, in my judgment, more consequential, which is that undergirding all of this is data. And I believe we are also in the midst of a data revolution, by which I mean the explosion in the data available from private companies, from social media, from governments, and basically every aspect of urban and social life at levels that I think are unprecedented. This is where I show you a picture like this, where there's quote-unquote big data, which is a term I'm not going to use, on everything from banking, insurance, education, healthcare, energy, etc. I believe everybody here already knows this. But what I'd like to make a case is that it's not actually the case that there's something strictly new about the fact that we have data on a large scale. We've always had data on a large scale. The East India Company amassed volumes and volumes of data over many centuries. Economists have been using data on a large scale for many years. I think what's new is 3 things. First, acquiring the data today is fast. You don't have to spend years in a library hand-coding anything. You can literally download terabytes of data in a week. You can download enough for an entire dissertation in a couple hours just by connecting to an API. I think the second thing that's new is that the data are comprehensive. They cover not just economic issues, which have always been well documented, but cultural issues, people's movement throughout cities, communications at an unprecedented scale. It's really basically, just about every major domain of social life is now captured. So they're really comprehensive. And thirdly, just as importantly, they're cheap. You can just get a lot of these data, frankly, for free. You know, back in the 1970s when researchers in sociology were doing large-scale surveys, they would have to get multi-million-dollar grants to obtain a nationally representative survey of the US population. Right now, my students can download the data from Facebook or Twitter, X, for free. Just literally, they don't even need to apply for a grant. So the fact that it's fast and comprehensive and inexpensive means that we're just flooded with data. It's very easy right now. In fact, if you're a quantitatively oriented PhD student in most of the social sciences right now, it might even be irrational for you to spend a lot of time learning how to conduct a survey and calculate power analyses and apply for grants and try to get 3,000 people that are nationally representative, because you could just spend a week and download data for free on something that somebody hasn't studied because there's just enough data on so many different things. I think we're in the midst of a revolution. Good or bad? Well, that's what we're going to talk about. I think the promise is clear. But I want to spend a little bit of time talking about the perils. For the moment, I'm going to set aside what I think are the two most important ones, which are ethical, having to do with privacy, right? When we're analyzing all that Facebook data and all that social movement, physical movement tracking data through our cell phones, there's a lot of privacy concerns that are worth addressing. And the second is control. Lots of people, including me, as I'll show you in a minute, analyze data from social media posts that the users didn't know were going to be used for, didn't really know were going to be used for social science purposes. There's issues that we have to talk about. I'm going to set them aside for the moment and instead focus on methodological and epistemological concerns, because I think they're more relevant to a lot of what we're doing today, even though I think the ethical ones are at least as important. And I want to talk about what I think is the biggest problem. I believe that as social scientists, we are in deep danger of falling to what I'm calling size-induced blindness, which is the tendency to ignore basic limitations in a data set, limitations that are endemic to the origins of these data as a result of the size. A lot of the data that we get, contrary to the surveys that I just talked about a few minutes ago, or an experiment that you might design to test an idea, or an ethnographic set of field notes that you collected yourself, or a set of interview, the data that we analyze now in the big data context are data that were produced by other people for purposes other than generating social science. Facebook's main interest is not discovering the world, it's making money. Reddit's main interest is not discovering social interaction, it's making money. When the government collects tax data, it's doing it because it wants the revenue. When social scientists use those data, they're doing it because they want to discover something about the world. The majority of the large-scale data that are administrative in nature were collected by other people for other purposes than the purpose of generating science, which was not the case when we did our own experiments, or do our own experiments, or our own interviews, or our own surveys, or our own ethnographic data collection. And I think that problem is, or the potential consequences of that fact are compounded when the data are large. Because who isn't impressed by a very large data set? But the problem, and this is the point in a nutshell, and I'll show you many examples of this, is that it results in a gap. A clever enough person with a large enough data set and enough time, in fact, today you don't even need that much time thanks to AI, you can produce a result. But producing a result is actually not the same thing as generating science. And what I'm going to hope to show you is that we have a lot of results right now that are not actual social science. They are either probably wrong, or misleading, or both. Now here's what I mean by science-induced bias. All of you have seen this, and many of you have probably done some version of this. You write an abstract, and you find the biggest number you can think of to put in the abstract. Here's an example from my paper in Nature. We use data on 21 billion friendships from Facebook. Oh my, right? So you see that, you're like, oh, of course, it's got to be real, right? It turns out this happens all the time. I don't even have to tell you this. Across the social sciences, the number of articles that refer to X million or X billion something is actually quite high. In fact, if we had the time, I don't have it here, I didn't think we'd have the time, and I was right. There's a nice study looking at the proportion of articles, even in economics, that use survey-based, representative survey-based data in the 5 major journals in economics, beginning in the 2000s up to today, and the number has tanked. And it's been replaced by papers like this. Now, what I'm going to tell you is that that impressive reaction that we all had when we saw 21 billion friendships has blinded us to important problems in this kind of work. That's it. And what are the problems? I'm going to talk about 5. One is selection, it's an easy one. Misclassification, lampposting, algorithmic confounding, and unobserved influence. Only one of those is jargon, and I apologize, it's not my term, but it's all very straightforward. Here it is. Actually, it goes earlier. We've been in the 1980s. The first is the obvious problem that large does not mean representative. I don't have to spend a lot of time on this, but going back to the 21 billion friendships on Facebook, not everybody's on Facebook. And so you can have a ton of people who are not a representative sample of any real population. That's pretty obvious. I won't spend too much time on this, but I'm going to give you an example from work we were doing. We were interested in a study of trying to understand how people made financial transactions and the extent to which the resources available to their friends affected the extent to which they used resources from financial institutions like banks or payday lenders. And we were talking about this, and my students said, oh, what about Venmo? And I thought, well, this is show you what's Venmo? And they said, what all of you who are under 30 know, and for those of you who are not under 30 or 35, Venmo is a very popular social media app that until very recently, many people used to, for example, pay your roommate or pay your part of a bill at a restaurant and so on. But what was great about Venmo is that it was a social media site. And so for many years, they probably don't do this anymore, Venmo opted you into posting whenever you sent money or received money. Exactly. And so there's a lot of data. And because anytime you send or receive money, you are essentially sending or receiving a tie. You're evincing a social tie. We thought, oh my gosh, this is amazing network data. The problem is, even though of a certain age, you might think, well, everybody is on Venmo. The truth is, not everybody's on Venmo. And in fact, the problem is not just that there's an age distribution for Venmo users, it's also a class one. For the particular problem we were interested in, again, in social inequality. And we wanted to understand how low-income populations used friends versus institutions when they needed money. Well, it turns out that thanks to conventional good old survey research, we know that rather than Venmo, Cash App, a different app, is far more common among low-income and working-class people in the United States than Venmo is. And so you could imagine that we have a study with X million, or we probably would have said X billion transactions on Venmo, because billion is more impressive sounding than millions, and have very interesting conclusions that have nothing to do with the actual problem that we're studying, because it's misrepresenting the population that we care about. A second problem is misclassification, which is that, again, as I said earlier, because the data that we often use were collected by people for purposes other than generating social science, we might have data based on categories that sound like the categories we care about, but that are not actually the categories we care about. This is actually part of the consequence of the fact that there's also now a data selling industry which produces machine-driven products, and I'm going to explain what I mean by that in a minute. This is also, I'm going to show you by example. This is a study we were doing of financial institutions. We were looking at six different kinds of financial institutions: banks, credit unions, payday lenders, etc. And we used a very popular data set named SafeGraph. Now, SafeGraph, the way SafeGraph works is SafeGraph first offered for free data to researchers like us, and then after those researchers, like me, published papers in fancy places, then they started selling those data to private companies, saying, hey, paper in journal X uses our fancy SafeGraph data, we're going to charge you a lot of money for it. Now, the way SafeGraph works, and I'm going to walk you through this because this is actually really fundamental. We're talking about the architecture of social science today. The way SafeGraph works is the following. SafeGraph, to obtain establishment data. So let me step back. Remember, we are trying to understand financial institutions in the United States, so we wanted to know about every single bank, credit union, payday lender, etc., in the United States at a particular point in time. We wanted to know what all of them were and where they were. Very simple question, right? Well, SafeGraph, the way it works is the following. It takes data from multiple sources. I'm going to invent the sources, but this is the process. Yelp, Google, etc. Pulls them together, creates its own data set, and says, here, we can tell you that there are 200,000 financial institutions, and we know that there are 200,000 because we have better data than any of these single sources, because we have data from multiple sources. Now, SafeGraph is a modern company, so there's not a collection of monks sitting there looking at the data from Google and by hand comparing it to the data, sorry, monks, I couldn't help it, comparing them to the data of Yelp. It's all machine done. Well, what happens? I'm going to get a little deeper into the weeds, but I think it's worth it. Think about Yelp. How does Yelp make its money? Do you know Yelp? Is Yelp popular here? Please raise your hand. Okay, Yelp is not as popular. Okay, Yelp is a review site where people, users, go to a coffee shop, a restaurant, a bar, and review it. And usually they say something interesting, profound, banal, often funny. And then other users like it. And so you get status when a lot of people think your post is funny. For example, when you reviewed a donut shop and you said something funny about it. So Yelp makes its money on engagement. What does that mean? That means that, for example, a coffee shop or a bank or a credit union closed and has a lot of reviews, Yelp has no interest in removing that because all of those posts that all of those people put in are still there engaging other people. I'm SafeGraph, I'm the aggregator. So I take all of those reviews from Yelp and all of the ones from, say, Google or whatever. And, well, it turns out that Google, in my judgment, well, in my machine learning's judgment, missed a whole bunch of establishments that were still at Yelp. And so I say, guess what? This group over here, this company only had 150,000 financial institutions. I have 200,000. I have the better data. And in come the social scientists and say, free data? And it's 200,000, so they're better. Let's write a paper. Well, it turns out that there was a fundamental misclassification problem that had we done that, we would have produced wrong results with a huge data set. And here's how we found it. The very first question we asked is a very simple question. Did SafeGraph classify the establishments correctly? For example, Wells Fargo is a bank. Did SafeGraph say, hey, Wells Fargo is like one of your 6 types. It's a bank. Or did it say, no, Wells Fargo is a waterfall or a well company, right? Which is possible because, again, all of it was done by machine. So we did a classification study. Here's what we found. Later I'll tell you how we did it. Yeah, we'll have time. Later I'll tell you how we did it. What you're seeing here is we did a comprehensive qualitative study of the 202,750 financial establishments SafeGraph said existed of our 6 types. You can see that in the bottom on the left. Right next to that is the actual number of those 6 types of establishments there were in the United States in that same time period when Safegraph said that when Safegraph reported the numbers. There were only 118,687. In a minute, I'll show you how we know, but we're quite confident. That is an enormous difference. And a lot of those extra places were exactly like what I just told you, places that were closed. Some of the errors were even more embarrassing. Imagine a bank is called Smith & Wesson Bank, but Google classifies it as Smith A&D Wesson, and some other source classifies it as Smith & Wesson. Guess what Safeguard had done? It had said, there's two different banks. One is called Smith & Wesson, and the other one is called I'm not kidding. ST period instead of street. FIFTH instead of the number 5TH, etc. Exactly. But today, you can imagine the incentive of just taking in 200,000, not doing all of the painful field work to figure out whether the data are right, and just running my regressions. There are a lot of papers out there with the wrong results. I'm quite confident of that. Oh, but it's even worse than that. They also misclassified the data. So some of the places that were, for example, credit unions, they called banks. And many of the places that were in fact payday lenders, they called something else. I will show you later how we know that. But that misclassification is actually quite a serious problem, again, because we're interested in urban inequality. We want to know, for example, what is the degree to which there are more payday lenders than banks in low-income neighborhoods? If you are misclassifying and not detecting that last category there, you see the 41.1? That is the probability that Safegraph accurately detected that a payday lender was a payday lender. 41%. It was off more than half the time. So all of our results about whether, for example, it's harder to find a bank than a payday lender in low-income neighborhoods would have been off by a major factor. But it's big data. So we would have put in, based on 200,000, an X number of transactions, we can say the following, because it's very easy for reviewers to be blinded to very obvious problems we would have detected in their context because of the size of the data. Here's, again, from a paper with Nicolita Grigoropoulos. Here's the proportion that were just closed. Look at consumer lending. A quarter were literally just closed. Yeah. All of you, I'm sure, can do the math very quickly on how off results can be. Third problem, it'll be a little fast. This is an easy one, lampposting. Which is basically what I'm using at the old joke about a drunk man in the middle of the night crawling around by a lamppost. Police officer sees and says, "What are you doing?" And the drunk man says, "I'm looking for my keys." The officer says, "Well, is this where you lost them?" It's like, "No, but this is where the light is." Turns out, it's funny when the drunk in the cartoon does it, but guess what? It turns out we do it all the time in social science research. And I'll give you an example. And just so that you don't think I'm just making fun of other people, I am the example in this case. This is again for a banking project. Back in 2006, I did a study of access. We were all interested about neighborhoods and where there is difficult to access financial institutions in minority neighborhoods. So the question is very simple. It says, little access. Are minority neighborhoods more likely to be banking deserts, places where you can't find a bank? That's really it. And at the time, we were like, well, we had actually begun with a small-scale project in a few cities, but shortly after we started, we learned that the federal government had just released an amazing data set called the ZIP Business Patterns Data, which is a data set that contained, according to the federal government, the number of establishments of every kind in every zip code. Big data in the whole country. So we thought, well, the zip code is kind of like a neighborhood, so let's just count the number of establishments of banks in minority neighborhoods and non-minority neighborhoods and see if the question of access is right. Very straightforward. So here's what it looks like, and here's the problem. So this is an imaginary city that has 3 neighborhoods, zip code 1, zip code 2, zip code 3. In zip code 1, there's no banks, so you'd call that the banking desert. zip code 2 is not a banking desert, but it's better. Zip code 3 is doing great. So we thought, aha, we answered the question of access. Here's the first problem, and I think all of the urbanists will be able to see this problem in like 3 seconds. Suppose these are 2 units of people, because at the end of the day, we're interested in the access of individuals. And we remember the fact, a zip code, by the way, is like a postal code. It's what it's called most often in Europe. Sorry, the postal code. Anytime I say zip code, think postal code. The zip code is a classification scheme developed by the US Postal Service, not for the purpose of doing neighborhood research, but for the purpose of classifying and delivering mail efficiently. So there's no natural connection between zip codes and places, except that to the extent that the post office at some point believed it would help it deliver mail more easily. They're not communities. So suppose we now look at life as it is actually lived, and we forget about the zip code. We just have a map with houses and banks. The first thing that we notice is that this house is actually closer to the nearest bank than the other one, even though that one was the one that was supposedly in the banking desert. So that part of the story was wrong. But now let's focus on that house for a moment. We all know that in cities there's such a thing as infrastructure. And particularly for cities that are not as walkable as central Vienna, infrastructure matters a lot. In fact, you can imagine that for that house, even though that bank that I pointed to earlier was the closest, it may not be the fastest to get to. It may be the case, for example, that to get to the bank, the person has to take the north to south train, get off, wait for the bus, and then take the bus across. Whereas if they take the north to south train all the way south, they might actually reach that little bank right in the corner there faster. Access, when we put ourselves in the position of the person trying to reach a bank, is not really a function of the neighborhood, it's so much a function of what you can get to, which is determined by socially instituted infrastructure. And so our view of access was actually wrong. Now you probably are saying, well, this is a pretty far-fetched example, made just for the purposes of illustrating this case, and you would be right. This example I manufactured for the purposes of illustrating this point, but it was based on actual fieldwork. So I used to live in New York, and I live in New York again, but many years I lived in New York, and this is Upper Manhattan. The green is Central Park, and the zip codes 10026 and 10027 are Harlem. This is a better representation. What you're seeing there in that little house is the apartment I used to live in. It's just in the northern part of Harlem. It was at 142nd on the west side of the city. Now, right before I moved there in 2001. Right before I was a baby. No, I moved there in 2001 when I was about the age of many of the doctoral students. And just before I moved there, in that star that you see there, a supermarket opened up. So this example is not about banks, but it's about supermarkets, but it's the same point. And it was all over the news. Harlem is no longer a food desert. That was the headline. And that was, in fact, the closest supermarket to me when I was there as a crow flies. But in the whole time I lived there, I did not go to that supermarket once. Why? Because to go to that supermarket, I had to go from literally walk to the train at 145th Street, take the train, north to south train down to 125th Street, wait for the crosstown bus. 125th Street is the main street in Harlem, the Apollo. That's 120. Have you heard of the Apollo in Harlem? If you've seen any street in Harlem, it's probably 125th Street. It's the most famous one. That's where it was. That's where the star is. So I had to go from 145th Street down to 125th Street, wait for the crosstown bus, and then take it across. It took an hour. Meanwhile, I could take an express train from 145th Street down to the bottom left corner of Central Park. That's Columbus Circle. I could be there in 17 minutes because it was an express line. Yeah. And if I kept going, in half an hour, I could be in Chinatown, in the southern part of the island. So I actually did more grocery shopping in Chinatown than in my supposedly no longer food desert neighborhood. Infrastructure matters. And as social scientists, what we care about is people's use of the city, regardless of the fact that it was happy that the federal government had released this fancy zip business data set that had every single zip code in the whole country. But we lampposted. We went under the lamp of the zip code data because that's where the data were. So yeah, I was the drunk. But we did it better. In 2018, we now have better data and more computational capacity and better algorithms. And so what we did is we did a new version of a study, much more refined, where we calculated the travel times. We looked at the middle of every block of each of the largest 20 cities in the country, and we calculated the number of minutes it would take to get to the nearest bank, whether by foot, or by car, or by public transit, because that is the access question. And for the study, we also compared it to Perry lenders. I'm happy to share the paper. It's based on 400 million queries. That's not what's good about it. I think it's a good paper, but not because of that. Oh, there it is. It's in Nature Human Behavior. 6 million. Sorry, wrong paper. 6 million queries. You gotta put the million so that the reviewers get it. It's totally, I mean, it wasn't cynical. You put it because it's part of the process. But you still ethically write a good paper, at least to the extent that you can. But here's what's interesting. If we had only used zip codes, we would have understated the extent of racial inequality. In other words, if you just look at zip codes like we did in 2006, you think that poverty is the primary driver of access to the nearest bank. But if you have the more refined data that we actually did, the effect of poverty is actually dramatically dwarfed by the effect of race, which was surprising to me, but I never would have discovered had I not stopped looking just under the lamppost and done the much harder work of figuring out how people actually use the institutions. Okay, 2 more examples. Algorithmic confounding. This is particular to platform-based research where the behavior you observe that you're trying to test as social behavior is in fact induced by the platform itself. Here's what I mean. Those of you in social network analysis understand the idea of triadic closure. It's a very simple idea. Think about triads and triadic closure in math, it's the same idea. So the idea is the following. If person A is friends with person B, and person B is friends with person C, there's triadic closure to the extent that person A is also friends with person C. That's it, okay? Now, this is a fundamental theorem in network analysis that social networks will have a tendency towards triadic closure, okay? That, in other words, if there's a triad such as A knows B and B knows C, there's going to be a strong tendency towards for A to know C as well. Now, for many years, we had tested this idea on small-scale samples. All of the faculty in one university, all of the students in a classroom, this kind of thing. And as data became bigger, people started saying, well, boo, you can't do that. Those are just unrepresentative, tiny little samples. You can't take them seriously. Now we have Facebook. And so why don't we test the idea of triadic closure on a sample like Facebook? And people have started doing this. Sounds amazing, because there are 21 billion friendship ties on Facebook. Well, here's the problem. Number one, the social science question that I gave you was triadic closure in friendship networks. If A is friends with B and B is friends with C, then A is likely to be friends with C. What's a Facebook friend? This is my Facebook, this is a post from my Facebook thing from a few years. I don't have 1,449 friends, I can tell you that right now. I don't even know the majority of those people. Facebook, of course, calls them friends, Because if I had called them something else, like, I don't know, fake ties or something more accurate, sorry, nobody would use it. The whole point is that it's a friendship connection site. It's an extremely obvious point. And yet it's an extremely ignored point because we're blinded by the data. Yeah, I actually only recognize 3 of the faces there. One of them is a former grad student. That's actually not even the worst problem. The worst problem is algorithmic confounding. So I just told you that the idea of triadic closure was a very simple idea in network analysis, very foundational idea in network analysis. Well, lots of people take network analysis courses. Those people include people who go to college at universities that teach them and then go on to work at Facebook, who learn that there's a tendency for triadic closure and say, when they hear, hey, we gotta increase engagement by increasing friendship ties, somebody says, hey, I know. Why don't we induce people to connect with the friends of their friends? And that's exactly what Facebook does. Now, let's step back from, all of you have seen this, but I just want you to step back for a moment and imagine, suppose you don't know anything about network analysis, and you're just creating a site like this from scratch. And you said, well, I want to help people figure out who might be their friend so they can connect. You might say, well, I'm going to take all of the sociologists and name other sociologists, maybe other sociologists in similar universities, or maybe all of the other people who are members of the of RC21 or whatever. Yeah? In other words, there's lots of ways of thinking about inducing friendship. But Facebook is inducing it through triadic closure. So what happens? You take your billions of friendships from Facebook, which are supposedly much better than the small-scale studies of one faculty or one college classroom, and you run your regressions, and you say, aha, I have finally shown with real data that there's triadic closure at a massive scale in the real world. That's a nonsense finding. It's completely wrong. Those aren't friends. Facebook induced it. You're observing algorithmic confounding. We don't actually know how much triadic closure there is out there in a large scale. We still don't know, even with all Facebook. What I'm saying, I hope, should sound very obvious, and yet it has not been the part of any of the studies, almost any of the studies that I've seen that use similar data to ask similar kinds of questions, where it's clear that the platform is inducing a lot of the behavior you're observing. Okay, last point. We're okay. Last point, which is unobserved influence. Now, this is again related to networks and related to cities, but this has to do with what's called the boundary specification problem. This is a simple idea that when you study a network, you always have to set artificial boundaries on it. So for example, when I said, I'm going to study, in the past I used to study all of the faculty at the University of Vienna, that's an artificial boundary. Because every single faculty member at the University of Vienna has colleagues or friends or acquaintances who are not at the University of Vienna and who are therefore not in the study. Okay? It's a simple idea. It's a kind of selection bias, but it's a constrained network. But the problem with that is that the influence of all of those people outside is unobserved by the researcher. This is a very simple and obvious problem. But when you have, for example, 21 billion friendships, who's going to pay attention to such technical things as huge selection bias problems? I'll give you an example. Suppose you're using Facebook data on all students in a particular cohort, the entire class of 2026, all of them, all students, to understand how students of different racial groups connect to one another. And you pick the single most comprehensively used site, which it turns out is Facebook. This is the proportion of people with accounts by age cohort. This is for a little paper we did, so sorry about the classification, but it's still useful. The millennial, Gen X, baby boomer. I don't love those categories, but it was useful for this kind of particular paper. But the point is, regardless of poverty and so on, there's way more penetration in Facebook use than anything else for all cohorts. So if you're going to use one, you're going to use Facebook. It's as good as it gets. If you use TikTok, you're going to have a way more selective sample, for example. Instagram, same thing. Facebook's as good as it gets. And yet, not everybody's on Facebook. So by definition, you're not capturing the influence of all of the people who are not on Facebook, who affect the relationships between the people in Facebook. You're also not capturing the dynamics among the people in Facebook who are connected on Facebook that happen outside of the classroom. I am never on Facebook. Even for the very tiny portion of my Facebook friends who I actually know, almost all my interaction with those people is outside of Facebook. And so if a researcher tries to understand any social phenomenon within the context of that network, ignoring that set of relationships outside of Facebook, you can have a completely skewed understanding of basically any process you think you're capturing. Race, it doesn't actually matter, because you're not capturing a lot of the truly influential factors. And third, just to push the point further in this particular case, but it's a similar idea, suppose you're interested in students, but you don't study the faculty, and you're interested in race relations. Faculty have an enormous influence on the students and on the dynamics among them by, for example, deciding what topics to pick, and therefore attracting students or not attracting students with the same interest in race-related issues. All of that influence is outside of the context of the platform. All of this is obvious, and yet, again, it's very easy to ignore it in the context of large-scale data. So yeah, I believe that there are a lot of studies out there with nonsense findings, but huge findings, huge data sets whose nonsense findings we essentially are blinded to consciously or unconsciously because we are impressed by the size of the data. I believe this is a real problem in social science today and that I think we should address it. Question is, what do we do? I'll just wrap up with this. I believe that qualitative research is not going to become less important. And it's also not going to be as important as it's ever been. I think it's actually going to become more important in order to assess the quality of the data that we're analyzing on a larger scale. And the example is going back to the SafeGraph example that I shared earlier. We did a misclassification study where we were just trying to understand that very simple question. When SafeGraph said something was a bank, was it really a bank? That was it. I'll walk you through what we did, just so that you can see an example. But there are lots of ways of doing this. So the first thing we did is we took those 202,750 names, and we did a keyword search. And we said, after confirming that this was true in general, if it has the word bank in it, it's a bank. And if it has the word payday lender in it, it's a payday lender. Turns out that won't work for every kind of establishment, but it works for financial institutions. So Bank of America, bank. Pentagon Federal Credit Union, credit union. That worked for a good number of cases, a high proportion of them, but not all of them. The second thing we did, and I'll give you an example of a case it didn't work for, Wells Fargo. It's not called Wells Fargo Bank. It's just called Wells Fargo, right? So what we did is the following. We took advantage of large companies. We took every name that occurred more than 6 times, and we isolated them. And then we studied those by hand. And then we figured out, okay, Wells Fargo, that's a bank. So then we went back and we classified every Wells Fargo as a bank. Okay? And then we learned, for example, every Advance America, even though it's not called Advance America Payday Lender, every Advance America is a payday lender because we qualitatively examined it. The algorithm can't do that for you yet. Although the algorithm will be able to do it better in the future because we wrote this paper. But there'll be some other new paper where somebody will have to do the manual work. So those 2 steps gave us about 80% of the cases. The third thing we did is we took all of the remaining cases and we did a search for the single most common terms. We used the computer, find me the most common terms. Then we took those terms and then we qualitatively studied them. What are they referring to, etc. So then on that qualitative evaluation, we reclassified, now that we knew what the terms referred to, entities. That's where we learned, for example, that a lot of payday lenders call themselves cash advance places. So then cash advance, if you had that term, you became a payday lender. On that basis, we classified another 5% of the cases. That still left us with 15% of the cases. For that 15% of the cases, we searched online for every establishment through multiple sources for each. We saw if it had a website. If it didn't, we looked at reviews on Google, we looked at reviews on Yelp, we looked if it had a Wikipedia page. We just looked at every single possible source we could find. Then, we said, okay, did we do it right? Because again, and I really want to stress this, getting the wrong story quickly because we had the cool large data set would actually be consequential. We're talking about resource access in low-income neighborhoods. People make policy decisions on the basis of our work. There's no way. So we checked the reliability of what we did. The first thing we did is, because I'm based in New York, we took a random sample of 243 of the financial institutions in New York, and we checked them. So for some, we just went to the neighborhood where we're supposed to be to see that it was there, and that we had classified it correctly. So now we're checking the work we had already done. For others, we just called. We either called or visited all of those 243. And then the second thing we did, again, we qualitatively picked up the telephone. I know. There are people right now in college who are saying, what? Yes, you can pick up the telephone and just call the place without texting them and asking them, hey, do you cash checks? Are you a payday lender? No, thank you, that's it. It's not that hard. But again, it's qualitative work that, 30, 40 years ago would have just called research. That is the research process. The last thing we did is we took a certified random sample of the whole thing, of 30,050 in the whole country, and then we trained an RA who had not been part of anything. We hired a new person and saying, here's how you think about what a payday lender is, what a check casher, et cetera, here's what each of them do. Now you classify them through any means you want. They spent months on this, and then we performed an inter-quarter reliability check. The inter-quarter reliability across the 6 categories ranged from 94% to 99%, which anybody who does field work would not be surprised, because if you go to the field, you'll just see things that you can't just see with the machines. And it was on that basis that we uncovered the misclassification, the duplicates, the misclosures that were large enough to alter the results. We don't show you this, but we have, in an appendix to the paper, we looked at what would have happened if you used the safegraphs as opposed to our understanding of what, we're out of time. Oh yeah, thank you. We're almost out of time. We're out of time, but this is it. And we found results different enough to actually affect the substantive conclusions. We have a paper in Nature Human Behavior where we argue that because of the increase in large-scale data, qualitative research is actually becoming more important. And I just gave you an example of that. If you're interested in this, I would invite you to look at that and email me with more ideas or critiques. And the last thing we're doing is we're putting together a volume to do this. It's titled Beyond the Algorithm. It's coming out with Oxford University Press. It has a whole bunch of authors from both sides of the Atlantic. The role of qualitative methods in the data revolution, which I hope I've convinced you, is not just for color or interest. It's actually to increase the quality of the research we're producing, because it's very easy to convince ourselves that instead of producing good-looking pictures that are meaningless, we're producing science. Thank you very much.